So before we get into talking about geometry, shapes, and forces and things like that, we should talk about how we depict molecules and the different ways we do it to show different things. So we have these things called molecular models, and models are obviously a depiction of a system or of whatever so that we can better understand it. A lot of times we have models for things that are really small, like we're doing here, like molecules or cells. And we have models for things that are really big, like the universe, which we can't see altogether, but if we have a model for it, it gives us some idea of what it looks like. Or for things we can't reach, like lungs or brains that you just can't jump into. We have a model for that, so we can see them without having to cut somebody open. So in chemistry, we're going to have molecular models, models that show what molecules look like. And we've seen one of these already. We've seen the Lewis dot structures. And the Lewis dot structures show us in a molecule what atoms are bonded to what other atoms, where there's non-bonding electrons, and things like that. It tells us, if we don't know the formula, it tells us the formula. We can count up the number of each atom in there and get the formula. But it gives us some idea how things are bonded together. Typically, Lewis structures don't necessarily have to give us shape, but if we know the shape, we can draw the Lewis structure to depict the actual shape. Okay. Then we have ball and stick models. These are going to go a little bit farther than what Lewis dot does, in that it's going to give us a three-dimensional representation of what the molecule looks like, the angles between bonds, the overall shape, what can move and what can't, and things like that. So ball and stick models, we have model kits here that we use to make three-dimensional models of molecules. This is simply a depiction of that. We can use different colors for the different atoms. You can see here gray is carbon, the red is oxygen, and the whites are hydrogen. So this gives us a bit more information than the Lewis dot structure does. It also gives us some information so we can draw the Lewis dot structure a little better. We can put maybe a little geometry or shape to it when we draw it. Then we have the space filling model, which basically is a ball and stick model, but now it has the atoms shown kind of with their size, with their electron clouds. So it's called space filling, and you can see that instead of being able to see the bonds, we just kind of see the atoms that are stuck together, and we assume that they're bonded. We can't tell if they're single bond, double bond, or triple bond, but we can see that the hydrogens are stuck on the carbons, which means we're assuming that they're bonded to the carbons. Space filling models are going to give us some information, like if we have reactions, and if we want to know if an atom or a molecule can actually interact with another molecule in the way it needs to do a reaction, and things like that. So we have different models for different things that we need to see. So that's it. We're going to move into more information in Chapter 4.